So last time also we covered softwares, like we learned how to make a sales bot, sales forecasting AI agent, right? So we understood what is Streamlit, what is Ubicon, what is Fast API, what is DVC, right? So first what we did was we trained a model which was trained on a data set of sales, right? So we had some data sets. So we trained our model on that sales data set, and then basically based on that training, we were predicting the test data set, the value of the label for the test data set. So once the model is trained, then we serve the model using Streamlit API, and behind the Streamlit inference app, we were using the Fast API, which was served using Ubicon, right? And fine. So basically, we implemented the prediction agent using the Ubicon and Fast API, and then we served the trained model using um, Streamlit, which called the Fast API on its backend. And finally, we built a end-to-end n8n workflow, right? So this was the end-to-end n8n workflow, where we were having our Streamlit app, we were having our Fast API, right? And if we just switch it on, we can see one minute. So we built a five node workflow where the first node and the last node was webhook. Webhook means the entire workflow is hidden behind an API. So whenever you call the API, the workflow will be triggered, and there will be a response generated by the execution of that workflow. So yeah, I'm just running n8n to show what kind of workflow we built last time. Yeah. So these were the workflows we made, right? And this was all sales forecast AI agent. In this, we had these six nodes, and the first node and the last node is a webhook. The first one is the response. If you double click on this, you can see there is a API which will be hit, and after clicking on this API only, this node will get triggered. This node will be bypassed, and then it will go to the prediction API. And this is an HTTP request node which has a predict API which is served through a fast API which is triggered by a Ubicon server. So this is running on local, where we predict the label for uh, yeah, we predict the label for the testing data. So once we predict the label for the testing data, the label was the sales prediction, right? If you execute this, then it is waiting for this call, and when you copy this and when you hit it from here, so now it has, yeah, this node has bypassed, it has failed because this server is not running yet, the fast API server. So we remember that if the fast API server is running, then the predicted sales will be calculated. If it was around 48,000, 46,000. So then we had an if node. So this node is called if node, uh, where we break the flow into two branches by checking a particular value. So this value is either a fixed value, a constant value, or an expression. If it is an expression, then you can use any value from the previous node. So on the left side is the input parameters of the previous node, and the output is the output of this node. right? So if you execute this, node execution successful because there was no predicted sales from the previous one. And if the predicted sales is greater than 35,000, it will go to the true branch. If it is, sorry, if it is lesser than 35,000, it will go to the true branch. If it is greater than 35,000, it will go to the false branch. So these are the, so this is the false branch, this is the true branch. So in these nodes, we are returning a response, right? So, so based on these nodes, we are returning specific response to the user. So this was the sales predict forecasting agent, right, in n8n, which is implemented using a fast API. And behind this fast API is a trained model, which is used to predict the sales in the future. Okay. So that's what we did. Basically, so this is a production level example where a user is using n8n AI agent, right? And that n8n AI agent is calling the fast API also, and it is calling the Streamlit dashboard also, and it is coordinating with the ML Flow UI software also to analyze which one is the best model. And ML Flow, as we know, although you had a hard time installing ML Flow, that's why I'm skipping that basically. So ML Flow is used to select the most optimized model, and that particular most optimized model is registered, and then that is deployed in production. So all this is also interfaced with within the n8n agent. So this was the n8n workflow which we created last time. We trained a model on sales dataset. We created a sales prediction API using the trained model, which was the fast API UVCon. And then using that API, we predicted the sales according to the input parameters provided by the user. And according to the predicted sales, we divided our answers into two parts, low sales or high sales. And then we returned the output. So this is an HTTP request node, which actually is like the API wrapper over the workflow. So the real workflow is only these four nodes. These HTTP request node will only just bypass, right, when you hit that particular API, and it will call the fast API, which is running on the local. And you can run this on, uh, yeah, you can run this on a cloud node also. So once you go to this node, then it will give you the predicted sales, and then you can branch it out based on the sales output. So if you want to see this, yeah, if you see this, so here you can see that this is a diagram on the which is deployed in a cloud environment, right? So you can see that there is DVC. DVC is a version control system which pushes the datasets into S3. S3 is a key value storage, just like maps. So many, I think Nikhil was asking that there is a hackathon going to happen on 1st April. So what are we going to do in that? So we are going to solve a problem. For example, we are going to design a hospital repository management. right? How you will enter patients, how you will remove patients, how you will find patients, all those things. Chiga, so for that you might use a map. You might use a key value storage. Key might be the ID, value might be a patient object. So the dataset is also like that. So all those datasets are stored in Amazon S3. So DVC is the version control system which manages all the datasets. It will pull the datasets from S3. It will push latest datasets into S3, and then the developer who is working on Visual Studio will fetch those datasets, and basically they will train the model. For example, it's a random forest classifier or it is a linear regression, right? Logistic regression. So they will train the model using that dataset, which is coming through the DVC. And then once the model is trained, then they will send all the experiments and runs to MLflow, and then the MLflow can be used to decide that which configuration of parameters is the best to be deployed, right? And this MySQL RDS is used to store all these runs and experiments data. Yeah, and this runs and experiments. So once the model is trained, then it can be used. It can be served through the Streamlit app, as we saw last time, right? And then this VS Code can be used to push the PKL file, the model, the code base of the pickle model, which has been generated after training into GitHub. Yeah. So this ML flow is used during experimentation also and during this monitoring also. So both the sides of employees. Since you are not able to install MLflow, that's why I'm skipping the MLflow part, but we focused on the Streamlit part and the n8n part. So today, what we are going to do? One second. Can we hide this by any chance? Okay. So today we are going to make a rack-powered autosuggest search. So first we will make it by Python using a fast index, using a vector database like Pinecone or VV8, and then we will implement it using a n8n software, n8n workflow. This is how the n8n workflow looks like in an industry. So suppose you are using Google search, you type iPhone 15, then there are some auto suggestions which will come up, right? So do I, and on the back end there is an entire service which is designed, right? What n8n, what it looks like, as soon as you click enter after clicking the query, then it will trigger the webhook trigger using that query. Somebody there or not? Okay, so once we have the query, then we will do some query pre-processing. We will convert this query into a into an embedding, right? That's what we do with transformers also, right? So first we tokenize the input sentence, then we have token IDs, then we transform the token IDs into vector embeddings using various NLP algorithms like word to vec, bag of words, CBOW. So once we have the embeddings, then we store it into a index database like Pinecone or VV8 or FIAS. We use FIAS, right, for designing the recommendation system. So then basically we use this database to do the RAG retrieval, and this RAG retrieval, this database already contains n number of queries. So once you enter the query, you'll be able to find out the closest n queries to this particular input field, and then that will be returned, and that will be responded to the user. So we have designed similar applications in our workshop also, but today we will see that how we can design it as part of n8n. Okay, so this is like the, yeah, so you can use this as your project also. Many students were asking. Okay, there is a chat message. Yeah, okay. So yeah, it's okay. Today is our last session, so try to ask as many questions as you want. And this end-to-end prototype will help you to find out that what kind of projects, semester-long projects you can do, right? So yeah, let's continue. So we will make this bot, and then I will give you some time to implement your own bot. For example, this PDF policy chatbot, personal HR assistant you will create. ठीक है? So let's start by implementing this bot on Python. Okay. So the, yeah, how many of you are able to install n8n on your local?
Sir, can you just give the installation process, sir, how to do? Last time because it was for me it was showing errors, so I have just rebooted my system, sir.
Okay, I can. Yeah, I can share.
Yes.
Yeah, I hope you got it. So basically, you will have to install the node.js first. That can be installed directly from the internet. If you are working on Windows, you will that will be an MSI file. So once the node.js is done, then you can open n8n. It will open. So if you see here, I have typed in it n8n here, and then finally it is asking for me to type O here. Right. Once you type O, then this opens in this particular localhost with this port. Okay. So this is how you install n8n and open the monitoring dashboard in your local. So now what we will do is we will just continue creating the Autosuggest bot. Okay. Okay. So first we will implement it on our Python. Then we will implement it as a workflow in n8n. Okay, here is the chat. So this is the JSON we are using, right? So you will create this JSON, and then you will install Fire CPU and sentence transformers, and then we will load the data from this JSON, and then finally we will store it into the Fire's database. Instead of this Fire's database, you can also use Pinecone or VB8. So let's try to do this here. So you can create a directory for Autosuggest. Okay. So here you can create a data.json, which I have pasted for you, and then you can create a
सर excuse me सर
yeah.
सर नॉट जेएस तो डाउनलोड कर दिया सर इंस्टॉल भी कर दिया उसके बाद क्या करना है
उसमें इंस्टॉलेशन गाइड में n8n टाइप करने को बोला ना, जो अभी मैंने भेजा आपको. You have to do this npm install n8ng. First, you see whether npm is there or not. After node.js is done, then you should be able to access npm. ठीक है. So now we are writing embed.py, where we will transform all these sentences given in the JSON into embeddings, and then we will basically feed it into the vector database. So this is the code for this. Okay. Okay, you can see in this that you have first you have to install transformers actually. So you should do this pip install. So you have to install the sentence transformer, the model which you are going to use to produce the embeddings, and then the database, vector database in which you will store the embeddings. So we are installing both these. So if I install, like it is installing, is already there. I would suggest to all of you also to install both these, because we are going to use this uh, in building our auto suggest bot. Okay, this is installed. So now you can see in the embed.py. First, we are loading the model. We are using this particular mini LM L6v2 model for sentence transformer. And then the JSON file, which contains 6 sentences, we are reading from that file and loading it into this data. And then what we are doing is For D in data, we are reading the text into texts. Then we are generating the embeddings out of each text, right? We are encoding using this sentence transformer model, and then we are storing the embeddings into the FIAS database. If you remember from our workshop, we have used this FIAS for recommendation systems. This readily gives you the closest nearest neighbors for any embedding. So we store all the embeddings in a numpy array and then add it into this index. First, we are creating the index using the number of features of the embeddings, and then we are adding all the embeddings into this index. Okay, so once the index is ready, then we are writing the index into files. Okay, yeah, any questions on this? Oh, you are writing something. NPMV. Okay, NPM is happening. No test specified. No, you have to like you have to type this particular command, right? This npm install n8n. This one. Okay. So once this is done, you can basically create the vector database. And once this compilation is done, then you can again basically create a reader of a query. So now our database is ready. Now, if a user enters any query, then we need to make sure that we get the five closest embeddings. So for that, we will write another function, right? We'll write a retrieval API, which will be written behind the fast API. This is taking some time. So Nikhil, are you able to install n8n?
Install overalls.
Alright, okay, cool. Why is this taking so much time? So I would suggest all of you to install n8n on your local. Then you will be able to play around with it. You can develop your new future projects on that. One more thing you can do, if it is not working in this shell, then you can create a virtual environment and import that virtual environment and then install the sentence transform because that will make sure that there is no dependency issue. Sometimes what happens is sentence transformer has a dependency which is not correct. For every version they change the contract of the API, right? So virtual environment makes sure that we are installing a version of dependency for both. Nowadays, downloading the transformers again, again phase also. So these are the advantages of a virtual environment, right? It prevents the dependency hell. ML projects often require specific versions of heavy libraries like TensorFlow, PyTorch, Scikit-learn. A virtual environment prevents these project-specific requirements from conflicting with other projects or your system's global Python installation. So it creates a sub shell. That shell has its own environment variables. Okay. And virtual environment works best with ML Flow because ML Flow encourages reproducibility. It is still installing this. Why is it taking so much time? Sentence transformer is not installed in this virtual environment. So it will work only when installing. Yeah. So till the time this is installing, what you can do is you can take the n8n JSON. Those who have installed n8n, they can try out that JSON in n8n. So this is the n8n JSON. What you can do is you can copy paste this in a notepad file and save it as a JSON in uh, yeah, save it as a JSON. Yeah, in the desktop. So we will name it as Autosuggest. Okay, now 8 out of these models are compiled, 2 more are left. So meanwhile, this autosuggest.json is there. You can go to the n8n workflow and import this particular JSON from your desktop. So this is your n8n. So I have copy pasted this JSON in this notepad file and I have saved it in desktop. You can see it here. It's already exists. So if you type all files, you will be able to see this autosuggest.json here. ठीक है? So this file I will import here. You can create a new model workflow and then import from file. So that will be okay. First test. Yeah. Desktop contains this auto suggest.json. If you bring it here, then it will give you the entire workflow for the auto suggest bot which we are just creating. Okay, this is still hung here, so we will just try to understand this entire flow. So first and the last node remains the same. We have a webhook trigger. So this entire workflow will be hidden behind an API, right? This API is looking something like this. So if you execute this right now, this webhook will wait for a call to the test URL. And when you hit this API from a different node, from a different browser, it is taking some. Yeah, so this is not registered. Okay. How is it not registered? Yeah. Okay. Yeah. So see, now this is working. Webhook trigger has bypassed because it is able to detect this API call, right? So now the next stage is the RAG retriever. So what we are doing in the RAG retriever is we are hosting the search API using a fast API, and the input is a JSON query, right? Queue. So that will be the query, and this query is fed into this URL. Search is an annotation or an endpoint through which we will call our trained autosuggest LLM. What we are going to write embed.py. Then that model will automatically run some embed.py code, and it will suggest some responses. Okay. But right now we haven't written that, so that's why it is saying the service refused the connection. So we have to run this as a fast API in Docker. Okay. So in the RAG retriever, we will get these. Yeah. So what is the nature of the output here? It will not detect. So basically, it should return a list of responses which are closest to the input query. And then in prepare context, what is it? Yeah, it will just set a key value pair, some key and some value. Right? So whatever responses we get, we will just set the context, and then they are calling the OpenAI chat also to fetch these suggestions. And then once we get the response, then we format the response and send it to the user. Okay. So this is how it looks like. The transformers is still okay now. What you can do in the meantime is you can make this bot on your own. This is your side homework. So you have to make a PDF policy chatbot, which will behave like a personal HR assistant. Okay, you will give some PDF policy which will define some ground rules, right? And then you have to build this bot using a RAG pipeline. You can use PyPDF loader to load the text. You can use the character text splitter to chunk the text, and then you can use FIAS to store the embeddings which you calculate of those texts. So it is very similar to the Autosuggest bot which we have created just now. Only thing here is like it will be a bigger PDF. It is not only 10 sentences or a single query, but you have to chunk that particular PDF. It can be a 20-page PDF. So yeah, spend some time, do some research, and figure it out. So are you will you be able to do this project? Like can you take some time out and try out? You can use internet, you can use ChatGPT and figure out how to implement this code wise, workflow wise, and then prepare a report, run some experiments, run some queries. So yeah, now this person is downloaded, so we can start maybe it end to end. Okay, so you can copy paste this. This can be your one of the semester projects. Okay, so I'll be back in 1 minute.
हाँ नहीं ये लोग तो करते हैं उन्हें प्रचार होते हैं तो हमें हमारे भी पुलिस जैसे ये इस बात का फायदा उठाते हैं तो वही तो कह रही हूँ, तो पुलिस को वही तो कह रही हूँ, पता नहीं मुझे पता कैसे उधर इधर सब अंदर सब हवा में तेज चल लेकिन वो तो ना उनकी रिस्पॉन्सिबिलिटी होगी तो वो तो और लोगों को अपने दिमाग यूज करना है ये प्रचार कर रहे हैं इसलिए ऐसे जिनका रंग का बड़ा
Okay, so let's try to build this. We already have sentence transformers installed. So let's try to embed.
बेटा कचरा है ये सारा फेंकना है इसको कचरा है ये हाथ में लगेगा वो रखे
शिवी शिवी आप वो फ्रिज में देख लेना, बहुत सारी पुरानी चीजें रखी हैं, ठीक है। This is just war. Worry about this. So the screenshot you have shared, Nikhil, that is just a warning. So I'm hoping that that is harmless. Even if you are getting it, it's okay. Is anybody able to like run this embed.py file? We can put some cout statements here. Only thing is this metadata. I don't know whether you already have this or not. Okay, interesting. Yeah, this Naga Srinivas always keeps entering and exiting. Okay, what we will do is we will write. Okay, I think sentence transformer only it is not. Yeah, I think the sentence transformer is an issue. Maybe this works only on the Colab, not on this local Python. So we can run this code in Colab also, but then we'll not be able to create the fast API. Okay, then n8n will not be possible. Okay, let's see. So does anybody understand what is fast API? I think why we will not be able to implement fast API on Colab? Yeah, this is running. And if you just remove this. Why it is not running? Yeah, this sentence transformer is an issue. So let's try to solve this. Okay, on local. So instead we can run Olama. First we'll have to download Olama. Okay. Then that is also another headache, right? Localhost API embeddings. So they are making running on this particular code. So this is also known as prompt engineering. Okay. We read about one shot, few shot, two shot, right? Zero shot. Okay, Hugging Face is the yeah is the ultimate option. So you can install the transformers, then use the bird base and case. I think we have done this previously also in our previous code labs. So yeah, let's install this transformers and torch. Okay, and do this. So we'll just replace our embed.py with this code. Let's see. So here we can see. So we should not. We should do all the knuckle with akal. Knuckle means you are copying the code, but you should copy it judiciously. So we should walk through the code. We are using Torch library, PyTorch. We are using NumPy. We are using the same database, using JSON, right? So we are getting the embedding. Yeah, this output is, yeah, inputs. So whatever text is there, we tokenize the text, and then with, yeah, we feed those tokens into the model, and then generate the output, and then we return the embeddings. So this get embeddings is used to create the array, which will be fed into the Fias database. That's it. That's what it is doing. So this is using the BERT model, BERT based on case and BERT based on case. Okay, so let's try to run this. Yeah, so here you can see, right? First you store this in outputs, and then you store it into embeddings. Then you return the NumPy version of this embeddings. Embedding is called here, right? And this text is the text from all the text from this data.js, all the sentences. So for each sentence, we are creating an embedding. We are creating an embedding using our model. First, we are tokenizing the input sentence. Then we are feeding the tokens into model. Then we are feeding those embeddings, the outputs into, yeah. Then we are returning those embeddings, and then we are using those data frame of embeddings and feeding it into Fias database. So these are the embeddings, and then we are creating an index and then adding the embeddings into that index. Similar what we were doing. Okay, cool. So this is in progress. You can see tokenizer is done. It is doing the next step. It is trying to train, basically create embeddings. Tokenization is done. Tokenizer config is completed. Tokenizer.json is generated. Vocabulary. You remember, right? Like tokenizer algorithms, there is a subword algorithm, there is a character tokenization. So every tokenization algorithm has a vocabulary, and the corpus can be converted into token IDs using that vocabulary. So right now it is, again here is So maybe let's try to create a collab where this works in a collab. Obviously, we'll not be able to do fast API, but one thing we can do is we can use an n8n agent. Okay, it is done half. So cool. 4 minutes 16 seconds it took. So I think 5 more minutes it will take. So we can understand the workflow till then, right? So once we have the embeddings, what we will do is we will create a retrieval and it will convert the query into an embedding. So this is the retriever API. This is the retriever file. Here you can see that we are deploying a fast API based on the model we have already encoded. We use the fast API in last class also, right? Right. And once we encode it, then we get the query vector. We get a vector, and then we create a numpy array of that vector and search the three closest vectors corresponding to the input query vector. Post process the output. This index actually contains two features. Contains the text, right, for all the indexes and return the results. So these are the three, right? So it is, I think, should be done nearly. So this is our retriever API. If, if we are able to run this for a particular input, for example, the data.json, right? It contain many iPhone queries. So you can type iPhone and see what all are the closest queries. So that and this retriever API I will send that. But this index.files they have written already here. Okay, so it's already done. It is not yet here, but we can write the retriever API. So this retriever API only uh, will be called by the n8n workflow. Okay, so we are saving it, and this retriever API will work only when once you have index.files in your local. So we are just waiting for this to complete. It will take 4 or 5 more minutes. I think.
मेरे फटाफट ना बन जाओ मुझे परेशान कर रहा है अरे भाई यहाँ पे कुछ मत करो अभी भी वॉश कराए सारा मैंने क्या कर रहे हो अभी ओ अच्छा मैं आ रही थी अरे वो यार एक आज मैं आई नहीं हूँ अगर ये चीजें छेड़ना है ना बहुत दिक्कत होती है मुझे उधर चलो बेटा शांति है आपकी क्लास कंप्लीट करो ना मैं तो बोलेंगे आपको कुछ नहीं मैं कर रही हूँ मैनेज नहीं कह रही मैं मैनेज कर रही हूँ आपको डिस्टर्बेंस ना हो ये भी कोशिश कर रही हूँ मैं वही तो कह रही हूँ सारा कूड़ा गिरा दे वगैरह अभी अभी पूरी बाल्टी लकड़ी है बैठ के कमर तोड़ के उधर भी जरा देख देखो एक चीज दिखानी थी मेरे को जल्दी जरा मैं आ गई बाहर आ जा हवा चलिए आप लोगों ने करा है क्या गिरा है वो वही तो वो एकदम
Okay, so this is done. Okay, so if you do ls, we will have a index.py here. So you can run, right? Um, so retriever you can run using uvcon, right? Last time we used uvcon, so this will run the retriever app using localhost and check whether it is running fine or not. And this is behind a search API. Okay, search is not there. Retriever. So once you have this retrieval API running, you can run it using uvcon. Then you can give a query also here. Somehow this is not detecting, but it should not be dark case. Oh, it is still compiling. Okay, okay, okay. Yeah, once this all this training is done, then only it will be available in local. That will take some time. Yeah, so actually this sentence transformer and you see right this one where you are calculating the embeddings. This one takes time on local. If we were doing it on Colab, it was easier, but here it is taking more time. Hmm. Yeah, it is nearly done. It will take maybe one more minute. Yeah, it is done. So this is also done. Record done. Tokenize it on this. It's done. Content on this. Okay. Now the startup is complete. So you can access this here and you will see an internal server error. Okay. What is this? Assertion error. Okay. There is something on the red block. Try once again. Ah, okay. This k is equal to 3. Hmm. Maybe it is not able to find three closest. Okay. There is some segmentation for it. Let's copy this one. Here. In this first node scores. Second node it is waiting. It is not happening. So we send the request, but the response was but yeah, I'm just giving session error. Maybe we'll reduce k to 1. Yeah, so this is a runtime error. There are two types of error: compile time and runtime. So this error you are getting when you are firing an input query on the already compiled Python file, and at that time it is saying that this particular file is awaiting this future. It is not giving any response. That is a problem. So let's try once more using case go to. Okay. So the local host comes up, but when we fire the query, then it gives it gives a runtime error. So there is no issue in compilation and serving it through the localhost, but there is an issue when we run the query. So the issue is in this. Yeah, this is complete. It is still giving an error. Okay, no problem. At least you got an idea that how to create this workflow for Autosuggest system in n8n. And similarly, you can complete your homework also, which is on PVI Pad. Right. So let's try to refine this workflow by embed.py. Okay, there are some shape mismatches, right? So in the embedding code, we are specifying this shape here. So there is some data mismatch. Okay, so we should replace this in our retriever. Okay, then you then you can reshape it. Okay, let's try this one. Okay, so this is guided debugging. Basically, you can whatever error you are facing here, you can type it in GPT and it will give you some probable solution. So let's try to run it once again. Yeah, this is running. Still giving an error. Okay, anyways. So another debugging integrator is saying that you can print this query worksheet. Where is index? Index is also there. Okay. So reshaping was already done. D type. Okay. So here the major issue is because we have a uncompatibility, right, in the shape which the particular model is expecting and what we are giving it to. So in order to remove that incompatibility, it is again reshaping it to 1 comma minus 1, and then this, yeah, ensure correct shape. Okay, anyways, you got the idea. You can just print these values and try to debug on your own. So once we have this running, then we can have the workflow also running here in the n8n. The rag retriever will also run, which will basically fetch the closest values, and then it will create a context of those closest values, and that context will be fed into the LLM OpenAI API generator. So this is also known as context engineering. Like we are just like there is a instruction tuning which we read right in our workshop, or few short prompting where we gave a couple of instructions in order to facilitate the response. So similarly here we are preparing the context from the FIS index. Once we have the context, then we feed that context into the LLM suggestion generator, which is the OpenAI API. Then we get the actual output, actual auto suggestion. Okay, so this is a probable project which you can do in your as a semester project, and then the n8n has an ability to generate code for this also. Okay, so the time is over. If you have any questions, you can read out to through diagram to me. And yeah, I hope this these 5 sessions were productive for you. So, in summary, we can tell that we learned about n8n, we learned about Streamlit, we learned about fast APIs, we learned about UVCon, right? And we started writing code in local also. Till now, we were writing code only on collabs. So that is, I think, the major good points of these online sessions. And we also tried MLflow, but you are not able to uh, basically install. But if that would have been possible, then we showed some demo on MLflow also, how we can do the tracking and fix the best model for MLflow. Take care. Okay, then take care. Have a nice day. I will see you on the hackathon day. Okay, take care. Have a good night.